Hello, everyone. Welcome back to the lecture number 2 of chapter coordinate geometry. That's chapter number 7 as per NCRT of your class 10th mathematics. And this is lecture 2, and we are going to cover three topics. What are those three topics that I will tell you in the next slide? And before we move to that, it's very important to go through like what's the weightage of this chapter as far as board examination and competitive examination is concerned. So as informed earlier as well, as far as board part is concerned, when I say board part, that means I'm talking about CBSE part. The weightage of this chapter is 6 marks. Okay, means you can roughly get questions carrying 6 to 8 or maybe 6 to 7. There is a little variation that might take place. And if I talk about the Olympiad weightage, Olympiad means SOF, IMO, and DSC examinations, etc. that we have. You can expect 2 to 3 questions, but yes, there can be variation sometime. Like you might see 4 questions also, or there is a possibility you might see 2 questions as well. So you can say roughly 2 to 4 questions you can expect from this particular topic. So it's very important to keep weightage in mind wherever you are studying any chapter. So this is something which is important, which you all should know. All right. So now we are going to move to the next slide to see what topics are we going to cover today. See. So the topics that we are going to cover today is the first topic is section formula. Very important formula. What is the use of it? How we got it? And how we have to apply it to solve the problems. All the three things we are going to discuss in detail. The second thing is it's a sub part of section formula, internal versus external division. That means when you are talking about section formula, you have two sub cases. One case is the case of internal division. The second case you have is the case of external division. We will discuss both. And the third thing, which is again derived from the section formula only, that is midpoint formula. As the name indicates, in this topic we are going to discuss how you can find out the midpoint of any line which is joining any 2 points. So these are the three topics that we are going to focus on in today's session. I hope you all got it. Okay, section formula is there, and then you have internal versus external division, and the third topic is midpoint formula. So let's start with our very first topic, that is section formula. Okay, it's very important to know what is section formula, or what is the benefit of this, or what we are going to cover in this topic. What does section formula says actually? Section formula, if you read this statement, it says very clearly, it gives you the coordinate of any point that is joining a line which is that is dividing a line which is joining any 2 point. For example, if you look at these two figures that you have, the first one and the second one. In the first one, there is a line which is joining point A whose coordinates are x1 and y1, and point B whose coordinates are x2 and y2. And this line that you have here, it is divided by point P, okay, whose coordinates we have assumed to be x comma y. And this point P that you have here, it is dividing it in the ratio m ratio m ratio n. That means AP ratio PB is m ratio n. So what are we given? Let's say you are given the coordinates of A, you are given the coordinates of B, and you are given the ratio in which this line AB is being divided by point B, whose coordinates we are already aware of. Then how you can find out the coordinates of this point P under consideration? That's what we are going to discuss. And this case will be a case of internal division. Why will it be a case of internal division? It will be a case of internal division because the point which is dividing the line that is joining A and B, that is lying internally or between A and B. Okay, so this case that we have, it is going to be the case of internal division. How we do it, that we are going to discuss anyway. No need to worry about that. Okay. Similarly, if I talk about case 2, guys, you can observe very clearly that in case 2, you have a point A whose coordinates are x1, y1. You have a point B whose coordinates are x2, y2. There is a line which is joining A and B. And there is a point P that is lying on the extended AB. Okay, you can see you have a point P whose coordinates are x comma y, and it is lying on the extended line AB. Okay. So this situation, like whenever you see this kind of case is referred to as a case of external division. And here this point P, which is dividing extended AB, this is dividing this extended AB in the ratio M ratio N. What does that mean? That means AP ratio PB, if you calculate, then AP ratio PB is going to be M ratio N. And this case is referred to as case of external division. Okay. So broadly speaking, what are we going to cover? Quickly, let us quickly do the recap of what we are going to cover. Section formula will help us to find out the coordinates of a point which is dividing a line joining any 2 points in a certain ratio. And when it comes to a point which is dividing a line that is joining any 2 points in a certain ratio, then you have two sub cases. One is a case of internal division, when the point which is dividing the line joining any 2 points is lying between the line, or it is lying on the line, okay, between A and B, you can say. Okay, that case is referred to as a case of internal division, which you can see very clearly on your screen. And the other case you have is a case of external division. What's the meaning of external division? External division means the point which is dividing the line that is joining A and B, it is lying on the extended AB, and the ratio in which it is dividing is M ratio N. So here we are going to learn in this topic how we can find out the coordinates of P in both the situations. I will discuss in detail the proof of one of the case for sure, and we will learn the application as well, like how you can use these formulas, what is the benefit, how you can use it to solve the problems as well. So that is, we are going to discuss that as well. I hope that's clear to everyone. I think we can move ahead. If anybody has any doubt till now, you can ask me, guys. All right, no doubt. Shall we move ahead? Okay, check out. So the first case we are going to discuss is a case of internal division, guys. So what are we going to do here? You can see this figure on your side. Okay, we have a point P whose coordinates are x1, y1. You have one more point Q whose coordinates are x2, y2. And this point M whose coordinates are x comma y is dividing the line that is joining point P and point Q in the ratio M ratio N. We are provided this. Okay. So here we are given, what are we given? We are given that the ratio of PM ratio MQ, that's equals to what? That's equals to M ratio N. Okay. And apart from this, you are also provided the coordinates of point P. The coordinates of point P are x1, y1, and the coordinates of point Q are x2, y2. So if this information is provided to you, then you have to find out the coordinates of this point M, which we have denoted by x comma y, like what will be the result for this. And because the point point M, which is dividing the line that is joining P and Q, it is lying between P and Q. Therefore, this is a case of internal division. All right. Have you understood what is given and what we have to find out? The coordinates of P are given, coordinates of Q are given, and PQ is a line which is joining P and Q. There is a point M which is lying between P and Q, such that this point P, this point M, it is dividing P and Q in the ratio M ratio N, and we have to calculate the coordinates of M. Okay. So let's see how we can do it. It's quite easy. It's not difficult at all. So I'm going to consider two triangles here, guys. Okay. One of the triangle is in triangle PSM. Okay. That's a right triangle. And triangle MBQ. Okay. So let me highlight the triangles that I'm talking about. I'm talking about triangle PSM. This is one of the triangle. The second is MBQ. Okay. I want to show that these two triangles which I have considered here, they are similar to each other. So in these two triangles, can we say that angle PSM, that is same as angle MBQ, okay? And both of them are 90 degree, right? They both are 90 degree. This angle is 90 degree. That angle is 90 degree, correct? Apart from that, what can be said? Because this line is parallel to this line, And this PQ that you have, it is acting as a transversal. So this angle will also be same. We can say that, right or not? We can say angle MPS, that's equals to angle QMB, because these two angles are corresponding angles. Okay. And because two angles of one triangle are equal to the two corresponding angles of the other triangle, so it can be said that the two triangles under consideration, they are similar to each other by double A rule. Like we all know what double A rule is. So by double A rule, these two triangles that we have considered here, they are similar to each other. Okay. So I'm writing that here. So you have triangle PSM, that's similar to triangle MBQ, okay, by double A rule. Okay. And whenever you are writing this result that one of the triangle is similar to the other triangle, you have to be very careful. Like you should write the corresponding vertex, like corresponding to P of triangle PSM, you have vertex M. Okay. So P should be written corresponding to M, as S is equal to B, so S should be written corresponding to B, and the same should happen for the third side. Okay. Now, what does we know? We studied this in the chapter similar triangles, that whenever we are saying that you have two triangles, and the two triangles which we are talking about, they are similar to each other. So when they are similar to each other, it can be said that the ratio of their corresponding side is also going to be same. So I'm going to use that result. Okay. So what do we have? We have PSM is similar to MBQ. So we will have PS upon MB. I'm writing it here. You will have, this implies you are going to have PS upon MB. Okay. That will be equals to what? That will be equals to SM upon BQ. Okay. That will be equals to SM upon BQ. Okay. And that will further be equals to what? If you look at the figure once again, that will be equals to PM upon PM upon MQ. PM upon MQ. All right. PM upon MQ. PM upon MQ. Right. Now let us see what is PS and MB in the given figure. What is PS? If you see this figure, can we say that PS is nothing but that's x minus x1? That's very clear from the figure. Okay. MB is x2 minus x. So I'm going to replace those two values. PS is x minus x1 and MB is x2 minus x. So you have x minus x1, x minus x1 upon x2 minus x. Clear? Then you have SM upon BQ. What is SM? This SM, if you observe very carefully, this side SM, what's this? This can be written as y minus y1. Okay. And this BQ that you have, it is y2 minus y. Clear? So you have y minus y1 is equal to y2 minus y. I'm writing it here. You have y minus y1 upon y2 minus y. Okay. And that's equals to PM upon MQ. If you observe this figure carefully, you can see that what is PM? PM is M and MQ is N. So M by N. M by N. Okay, that's what we have. Now, what we were interested in, guys, we were interested in finding out the values of X and Y. When we are already provided the values of X1, Y1, X2, Y2, and M and N. So let's divide, or let's have two subcases now. First subcase will help us to find out the value of X. So case first is, if I equate this first ratio with this M by N, and if I solve it to get the value of X, let's see what are we going to get. So I'm going to equate the first and the third ratio. You will have X minus X1 upon X2 minus X. That will be equals to M over N. And if you solve it further, you do the cross multiplication, you will get NX minus NX minus NX1 is equal to MX2 minus mx. Okay, because we want to find out the values of x, so you can transpose the terms having x on one side and the remaining terms on the other side, and while transposing, keep this in mind that the sign also changes. So you will be getting nx plus mx, correct? And that will be equals to what? That will be equal to mx2 plus nx1. On the left hand side, you can take x common, If you take x common, you will have x multiplied to m plus n is equal to mx2 plus nx1. That's what you will have. So what is the value of x which we are going to get as a result? The value of x which you will get as a result will be mx2 plus nx1 upon m plus n. This is one of the very important result, or this result gives you the coordinate, x coordinate of the point m which we were supposed to find out. Okay, clear? Now, what do we need? We want to find out the value of y as well. So to find out the value of y, we are going to equate the second ratio to this m by n. So let's do that. You have case 2. You have case 2. Okay. So if I equate this y minus y1 upon y2 minus y to this m by n, and if I solve it again in the same way, I'll be getting ny minus ny1 is equal to my2 minus my. That's what I'll get. Then let us transpose the terms having y on one side and the other terms on the other side. So you will get ny plus my, that's equal to my2 plus ny1. Okay, so what is the value of y you will get? The value of y which you will get is my2 plus ny1 upon m plus n, upon m plus n. Understood? Is that clear? That's a value of y we have. Clear? So what we were supposed to find out in this topic, we were interested in finding out the coordinates of point m, right? Coordinates of point m, which are x comma y. Okay, so what are the coordinates of point m? Therefore it can be said that the coordinates of point m bisection formula is given by mx2 plus nx1 upon m plus n, comma, you will have my2 plus ny1 upon m plus n. Okay, so this is the section formula in the case of internal division. You should remember this formula. It's very easy to remember. It's just a matter of practice. If you practice a handful question based on this case of internal division, I am 100% sure आपको ये formula याद हो जाएगा. You will quickly and very easily remember this formula. You can go through this proof once again. I'm giving you 30 seconds. If you have any doubt, you can ask. I'm highlighting whatever is important, guys. This result is important. Any doubt to anyone on in anything? Understood? Shall we move ahead? All right, check out. So now we are going to learn the application of this formula, like how this formula is going to be applied to solve the problem. So check out, it's not a difficult thing, it's quite easy. What are we provided in this problem? We have to find out the coordinates of the point which divides the line segment joining the points 4, 6 and minus 5, minus 4 internally in the ratio m ratio n. Okay, so let us try to draw a rough figure. So 1 second. Let's say this is one of the point A. It has coordinate 4, 6. That is the second point B. It has coordinate minus 5, minus of 4. Okay, and let us join them. AB. Okay. Let's assume there is a point P which is lying on it, and this point P, it is having coordinate x, y, and this is dividing this line AB in the ratio 3:2. Okay, 3:2. That's what we have. Okay, and you have to find out the coordinates of point P. So here, what's the value of x1 and y1 we have? I am going to assume the coordinates of A, which are 3, 6, that denotes the value of x1, y1. That's what you can assume. The coordinates of point B, which are minus 5, minus 4, they denotes the value of x2, y2. Clear? And this point P that you have, it is dividing it in the ratio 3:2. So here you can say m ratio n. That's equal to 3:2. Okay. We have to find out the coordinates of point P. So as per section formula, the coordinates of point P will be given by this formula, right? mx2 plus nx1 upon m plus n. This will be the x coordinate. Then you will have my2 plus ny1 upon m plus n. That will be your y coordinate. Okay. Now let us substitute the values. What will you get? You will get 3 into minus 5 plus 2 into 4, right, upon 3 plus 2. That will be the x coordinate. Comma, you will get 3 into minus 4 plus 2 into 6 upon 3 plus 2. Okay, that's what you will get. Let's simplify it more. You will be getting, this is going to become 8 minus 15. 8 minus 15 upon 5. And y coordinate is going to become 12 minus 12 upon 5. All right. So you will have minus 7 upon 5 comma 0. That means the coordinates of point P, which is dividing the line joining A, whose coordinates are 4 comma 6, and B, whose coordinates are minus 5 comma minus 4 in the ratio 3:2, is given by minus 7 by 5 comma 0. That's the answer to this result or this question. And what does this coordinate say? Because the coordinates that we got as a result, like the answer that we got, basically it has y coordinate 0. And what does it denotes that y coordinate is 0? Y coordinate is 0 means this point which we have calculated, it is lying on x-axis. Okay, so the point P that we are talking about in this problem, that lies on x-axis. That should be very clear to you. Okay, that's an additional thing actually. Like this additional thing is very clear from the result that we have just now. Okay, so I'm writing that additional thing as well. That is P lies on x-axis. Okay, understood? You have 30 seconds. Go through the entire solution. If you have any doubt, feel free to ask me. I hope it's clear. Shall we move ahead? Okay. So you can check here, they have done it in the very similar way. You can go through this solution if you would like to. The x coordinate is going to be minus 7 by 5 and the y coordinate is going to be 0. And they have used the same formula. That's the section formula. It's just that you have to put the value and you have to be a little careful when you do the calculation. If your calculation is right, your answer will be right automatically. All right. So let's move ahead. Now, guys, we have case of external division. I told you the meaning of external division. What's the meaning of external division? External division means you have a point P whose coordinates are x1 comma y1. You have a point Q whose coordinates are x2 y2. Okay, I'm drawing here as well. You have P and this point P has coordinate x1 y1. Then you have a point Q. This point Q has coordinate x2 y2. All right. And there is a point R which is lying on the extended PQ. You have to be very, very attentive here. This point R, which is dividing PQ, it is not lying between PQ, but it is lying on the extended PQ. So let's say this is R and it is dividing, it has coordinate x comma y. Let us join them. So this is what we got. Okay. And let's say this point R that we are talking about here, it is dividing it in the ratio m/n. That means this value is m and that value is n. So in this situation as well, believe me, like there is no major change as such when it comes to the formula. All that is going to happen in, like we know the formula for the internal division now. All you have to do is you have to replace the positive sign that we were having in the case of internal division by negative sign. If you replace that, you will get the formula here. So see how easy it is. If you know one formula, that means you already know the second formula. So here, the coordinates of point R that you have, that would be given by mx2 minus nx1 over m minus n. Okay. comma my2 minus ny1 by m minus n. Okay, so these are the coordinates of point R, which is dividing the line that is joining P and Q externally in the ratio m ratio n. All right, the only change would be in the sign. The positive sign that we were having in the case of internal division, that is going to be replaced by negative sign. No other change will be there. And yes, you have to keep this in mind. Like you have to be very careful when you do the problem whether they are saying internal division or external division. Okay, if they are saying external division, do not forget to use negative sign in the formula. And if they are talking about internal division, forget negative sign, you have to use positive sign. You can note this formula and I will tell you how we can apply this formula to solve the problem. Please note it quickly. I hope you all are done with it. Okay, let's move ahead. So here we are going to discuss a problem based on external division. So let us quickly go through it and see what information has been given, what we have to solve. You are given a point Z whose coordinates are 4, y and a point X whose coordinates are 7, minus 1. And there is a point Y which is dividing line ZX externally. This word that is written here externally, this is very important. Okay. So externally, it is dividing it in the ratio 4:3. So let us see what all we are provided here. Okay, I am provided coordinates of Z. Okay, which are 4, 5. So this is same as you can say this denotes the value of x1, y1, right? Apart from this, what do you have? You have coordinates of point X that are 7, minus 1. So these two values denotes x2, y2. Understood? And external division is taking place. So which sign do we have to use while applying the formula, while applying the section formula? The sign that we have to use or that you should keep in mind while applying the formula is negative sign in the case of external division. And what's the ratio here? Here the ratio that we are given, that's m ratio n, is 4:3. Okay, we have to find out the coordinates of y. So let coordinates of y be x, y. Okay, let coordinates of y be x, y. Okay, then as per section formula, what will be the for, like how are we going to get this coordinates of y? The coordinates of y will be given by mx2 minus nx1 divided by m minus n. Y coordinate will be given by my2 minus ny1 divided by m minus n. Okay, that's what you will have. Let's substitute the value. So we will have y is given by m, which is 4 into y2, that is 7. So you will have 4 into 7, okay, minus n, which is 3 into y1. So 3 into 4, okay. And in the denominator, you have m minus n, that is 4 minus 3, comma. You have 4 into minus 1, 4 into minus 1, minus n, that is 3 into 5 upon 4 minus 3. That's what you have. If you simplify it more, what will you get? Here you will be getting 28 minus 12 upon 1. Okay. Here you will be getting minus 4 minus 15 upon 1. Okay. So what are the coordinates we got? The coordinates of y will be 28 minus 12 is going to give you 16, and minus 4 minus 15 gives you minus of 19. So that means the point y, which is dividing the line that is joining z and x, whose coordinates we are already provided in the problem, is given by 16 comma minus 19. And yes, it is dividing, this point y is dividing zx externally in the ratio 4:3. You can go through the entire solution. Ask me if you have any doubt. So you have 30 seconds for that. Please do that. All right, any doubt? Shall we move ahead? Okay. So you can see they did in the exact same way, and you can see the answer is exactly same to what we got. That is 16 comma minus 19. But yeah, I have to be a little careful when it comes to the calculation, except that there is nothing tough here. Okay. This is interesting and super easy. Okay. Midpoint formula. What does midpoint formula says? As the name indicates, let's say you have a line which is joining 2 points. A, okay, it has coordinates x1 comma y1, and there is one more point B whose coordinates are x2 comma y2. Okay, let us join AB, and let's say there is a point P which is lying on AB. Okay, and this point P, it has coordinate x comma y. Okay, such that this point P that you have, it is midpoint of AB. It's midpoint of AB. So what is the meaning of midpoint of AB? Midpoint of AB means the ratio that you have. Okay, if I, let's say, assume this is M and this is N. So as this point P that we have here, it's a midpoint. At this point P, it's a midpoint of AB. So this ratio that you have, M ratio N, that is going to be exactly same. Means the value of M and N will be same here, right? So here we have AP is equal to PB. Okay, that means we can say we have M is equal to N, right? This is an important point here. Now, if I use section formula here, so using section formula, the coordinates of point P will be given by mx2 plus nx1 upon m plus n. Okay, y coordinate will be given by my2 plus ny1 upon m plus n. Okay, but you know what's the best thing here? The best thing is, or the point that we need to keep a note of, is that m and n both are same. So what you can do is you can either replace n by m or you can replace m by n, and let's see what we are going to get. Okay, so if I use this first result, what will I get? I'll get P is equal to mx2 plus mx1 upon m plus m, right? That's what I'll get. Here I'll get my2 plus my1 upon m plus m, right? That's what I'll get. And this is from result number 1 because m is equal to n. Okay. If you simplify it more, you will get P is equal to, you can take m common from the numerator, you will get x1 plus x2. In the denominator, you have 2m. And here again, you can take m common, you will get y1 plus y2. In the denominator, you have 2m. So m will get cancelled, right? So what's the value of P you got? P, the coordinates of P are given by x1 plus x2 by 2. That's x coordinate. Y coordinate will be given by y1 plus y2 by 2. That's a y coordinate. So that's like, this is what midpoint formula says. It says that if you have any point P, or you can give it any other name also, that is joining a line which is joining any 2 points x1 y1 and x2 y2, then the coordinates of that point under consideration is given by x1 plus x2 by 2 comma y1 plus y2 by 2. So as I told you, it's very easy to remember as well. So that's it. So this is basically, you can say, a sub case, or you can say a result of section formula only, in which the both the ratios that we consider while discussing, be it internal or external division, that is exactly same. That's m is equal to n. So if you replace m by n or n by m in the section formula itself, you get what we call as midpoint formula. You can note it, then I will show you the application of this. Okay, done. All right, so now let us discuss the application. This is an important problem as well, guys, because you might see this type of problem in your board examination as well. but it is very easy also. What are we provided? In this problem, we are given the four vertices of a parallelogram A. This is A whose coordinates are minus 2 comma 3. You have B. Okay, we have A whose coordinates are minus 2 comma 3. You have B whose coordinates are 3 comma minus 1. Okay. You have C, the coordinates are P and Q. You have D, the coordinates are minus 1 and 9. Okay, that's what we have. They are asking you, if this happens, then what will be the value of P and Q? Okay, what will be the value of P and Q if you are provided the coordinates of the four vertex of any parallelogram? So here you need to keep in mind one important property. Let me write that. That is, the diagonals of parallelogram bisect each other, right? Diagonals, diagonals of parallelogram bisect each other, bisect each other. Okay, so this is an important point that you should keep in mind whenever you are doing this problem. And it says that whenever you are talking about parallelogram, the diagonals are always going to bisect each other. Okay, so we are going to have two cases. Like, we will be calculating the coordinates of point O, and for now I am denoting the coordinates of point O by x comma y. So we will calculate the coordinates of point O by, like in two ways. One way will be while considering A and C, and the other way would be like when we will consider B and D. Okay, so case one I have. Okay, considering B and D, considering B and D. So if I calculate the coordinates of point O using midpoint formula, what will I get? Using midpoint formula. So what will I get? The coordinates of point O will be, that will be 3 plus minus 1 by 2. Okay, so you will have 3 minus 1 by 2 basically, comma minus 1 plus 9 by 2. That's what you will have. If you simplify it more, what will you get? You will get 3 plus 1 by 2, that is 2 by 2. And here you will have 8 by 2. So that is going to give you 1 by 1 comma 4. Okay, so that's a coordinate of point O when we considered B and D. Okay, now we are going to find out the coordinates of point O considering C and A, and because both the results are giving the coordinates of the same point O, therefore they must be exactly same, right? That's a concept we are going to use here. So we have case 2. Case 2, if I consider A and C. So if I consider A and C, and if I calculate the coordinates of point O using midpoint formula, what will I get? I'll get P minus 2 by 2, right? Because here this is x1, this is x2 by 2, and you will have Q plus 3 by 2. Okay. Now, what's the important point? The coordinates which are given by the first result and the coordinates which are given by this second result that we got just now, they both are denoting they both are actually giving us the coordinate of the exactly same point. Okay, so from 1 and 2, because they both are denoting the coordinates of exactly same point, so the x coordinate in both the cases must be same and y coordinate must be same. Okay, so you will have P minus 2 by 2, that's equals to 1. So what will you get? You will get P is equal to 4. Clear? P will be equals to 4. And you will have Q plus 3 by 2. That's equal to 4. So you are going to have Q is equal to 5. 5. Okay. That means the coordinates of point P, that should be 4 comma 5 for the conditions that are given in this question to be true, or for this parallelogram formation to take place. I hope you all got it. But yes, before you approach this problem, you need to know the properties of the parallelogram. If you're not aware of the properties of parallelogram, you will get stuck. Okay, so that's a prerequisite or pre-requirement that we have. You can say. Okay, you can go through it. Have 30 seconds. Ask me out if you have any. Okay, is it done? All right. Then you can see we got P is 4 and Q is 5. So they also got the exactly same answer. This solution is for your reference, guys. In case you do not understand, you can go through it. But the process, the way it has been done is exactly same. And this is the important point which I'm going to highlight here. We know that diagonals of a parallelogram bisect each other. This you should know basically to be able to do this problem. All right. Next, what we have. All right, so we have three problems that you have to practice as a homework. Let me quickly explain what all you have to do. The first problem says find the coordinates of point P. Okay, find the coordinates of the points which divides the join of P and Q in the ratio 2:3. So it's super easy. I like this is the direct application of the section formula that we did today. You are provided x1 y1, you are provided x2 y2, you are already provided m ratio n. You have to find out the point which is dividing the join of P and Q in the ratio 2:3. All you have to do is you have to put the values in the formula and you'll get your answer. That's it. In the second one, you have find the point of bisection, okay, of the line segment where A is this, B is this is again very similar. Okay, like nothing new is here. And the third one says find the coordinates of point P which divide the join of A and B in the ratio 7:3. Again, this is an application of section formula only. So these three problems that are given here, you guys have to try as a homework. And in case you feel stuck or you feel your answer is not correct or you're not getting the correct answer, you can always discuss with your respective subject expert. And yeah, that you can discuss with your subject expert. So let us quickly go through all that we discussed today. The first thing that we covered today was the section formula. What is the section formula we covered? How we got section formula? We did the derivation as well. The third thing we did is how to apply that section formula. What we did then? After that, we did the application. After the application, we discussed the case of internal division. Internal means the point which is dividing, the line joining two points lies between them. Then we did external division, the point which is dividing, the line joining any two points, and that lies on the extended part. Thereafter, what we discussed midpoint formula, which is the you can say a special case of the section formula where the two ratios under consideration, they have same value. That means m and n both are same. So that was midpoint formula. We did problems based on all the three concepts that we covered today, and these are the three problems that you have to try in your session. So that is this from this session. I hope you enjoyed it. So see you all in the next session. Take care. Goodbye. Thank you.